Namaskar, my dear friends. Let us talk about how we can design low pass filter using active element. That is what we will do is we'll try to use op amps to design low pass filter of our required frequency, let us say FC. So FC is my cutoff frequency, which will be calculated by 1 by 2 pi RC. So how does active element low pass filter looks like? So let me give you an example. So this is the low pass, like filter, and we have FC. This is my cutoff frequency. So up to this, the signal will be allowed. So this band is called as pass band from here to here, or it can be called as also bandwidth. Okay. So that is my pass band, which is allowed to pass, and after that it is called as stop band. And this is the actual, like low pass filter that will look like. Okay. Now, if you take it ideally, it will be exact, like rectangular type, exact. There is sharp cutoff. So that is ideal. That is not possible to design. We have already seen using RC how to get your passive element filters, right? So this is RC filter. Using that, FC will be 1 by 2 pi RC. However, coming back to the active element, we are going to use op amps, and this op amp, you can see we have RC element again, same fashion, it is RC element here. Okay. In this as well, you are going to get your cutoff frequency as 1 by 2 pi RC. If you want to see the theory how to get your how to calculate this particular cutoff frequency and gain and everything, you can see theory videos in, like some of the videos that is available in my channel. However, this R2 and R1 is going to set the gain. So we are going to like design the same filter using multisim simulation. Okay. So as you can see, let us say I have taken an op amp and I am going to put, let's say, R1 and C4 here it is. Okay. So 10 kilo ohm, 1 nanofarad, and this is my RC filter at the output, and now at output we are going to see the result. If you want, you can see the result at this place directly, not a problem. And I have kept it in buffer mode, that is gain will be unity. There is no gain that is going to occur. Okay. So now if I run, what are the things that you have to take care of? Go to simulate, analyze and simulation, and come to AC sweep. Okay. And in AC sweep, you are going to set your initial start frequency and stop frequency. So I'm going to take 1 hertz to 10 megahertz. If you want, you can put it to gigahertz as well, kilohertz as well, not a problem. Then keep the sweep type to decade and number of points per decade. Generally, you can keep 10, and vertical scale will change it to decibel. Okay. And now if you run it, you are going to get a very nice low pass filter like this. See, this is the magnitude curve which is going to 0 dB, and after cutoff frequency, it is going to come down. So how to check the cutoff frequency for this particular low pass filter is, you have to go to cursor, show cursor, and in this cursor you will see you have x1 y1, x2 y2. So there are two cursors. So I am going to change this. So you can see y2 is varying, minus, like y2 is varying. So I'll go up to minus 3 dB. See, so it is going to go to minus 3 dB. Let us say where it is. Yeah. So you can see it is 15.9 kilohertz. Okay. And what you can do is you can put your Excel sheet or your calculation 1 by 2 pi RC. How much is the, like cutoff frequency that is coming. So I'm going to just quickly put 10 kilo ohm and 1 nanofarad. Let us say this is, I'm going to put 10 kilo ohm. So that is 10,000 farad. 10,000 ohm, and this is 1 nanofarad is 0.001 microfarad. So you can see 15.9 kilohertz it is 15,915. So 15.9 kilohertz. So this is how you design the circuit for low pass filter. Let us say you have to have a desire of particular cutoff frequency. I don't want to calculate from R and C. I want to have FC and then decide a value of C, and similarly we will get some value of R. So let us say 1000 hertz we want to design. Okay, that is 1 kilohertz. So for that we can have 0.1 microfarad and 1.59 kilo ohm, that is 1591 ohm. Okay, so can we change the value? So I will change it to 1.59 kilo ohm. Okay, and this is going to be 0.1 microfarad. Now you will see the 3 dB cutoff frequency will shift to 1 kilohertz. Okay, that is 1000 hertz. So this 3 dB will shift here. So shall I run and show it to you? So let me run it. I am going to make this circuit little smaller so that you can see the circuit very nicely. Okay. Okay. And before that, what I'm going to do is the output was at this location, right? The output was yes. So what I'm going to do is I'm going to show it to you the output we had taken at this place. Now I'm going to take at little, like a further place, like after RC. So you will see a little bit much more compensated value will come down. Okay, so that is not a problem. Let me just do it. 1.59 kilohertz, 1.59 kilo ohm, and this is going to be 0.1 microfarad. So my cutoff frequency will shift to, from 10 kilohertz it will shift to 1 kilohertz, right? So let me run it and show it to you. Yes, so you can see we have 1 kilohertz. Okay. Now okay, so this is the like simulated value of this particular filter, which is going to be, we calculated 1.59 kilo ohm and zero point 0.1 microfarad for 1 kilohertz cutoff frequency. And for that, go to cursor, show cursor, and in this cursor you will see this particular y2. I'm going to bring it to minus 3 dB. So minus 3 dB is almost, yeah, 2.97, almost it is. So 990 hertz you can see, right? X2 position is 990. So it is up to you, like how you drag the cursor and see the value of y2 and x2. So keep it at minus 3 dB and you will be able to see 1 kilohertz. So based on your requirement, whatever the value of R and C you want, you can put it accordingly. Your FC will be calculated. Or otherwise, if you have a desired cutoff frequency for your low pass filter, okay, low pass filter cutoff frequency, then then you can put your desired frequency and assume a value of capacitance. Then accordingly your resistance will calculated. Okay, resistance will be calculated. So let us say I want to design a cutoff frequency for 5 kilohertz. Okay, so 5000 hertz I will put, and similar to that you can see we have 318 ohm. So if I change this value to little lower value, so 3.18 kilo ohm or 3.1 kilo ohm I will put it. Okay, so let's design for 5 kilohertz. So we are going to change it to 3.1 kilo ohm. Okay, and this will be 10 nanofarad, that is 0.01. What was the value? 0.01 microfarad, right? So the cutoff frequency will shift to 5 kilohertz. Okay, now I will rerun it. So you can see the cutoff frequency has shifted to 5 kilohertz. Let me drag and see minus 3 dB frequency. So minus 3 dB frequency, you can see it is 5 kilohertz. So this is very nice understanding of designing the low pass filter. Now you must make sure the output signal. If you want to see the output signal, what will you do? Go to simulate and analyze and simulation, and interactive simulation I'll put it, or maybe transients I'll put it. And transient I'm going to see this 0.1 micro, 0.1 or 0.001 second, that is 1 millisecond. Let us run it. So you can see the output signal is little bit like attenuated, means it is not reaching to up to +1 and -1. Why? Because the input frequency is 5 kilohertz. That's the problem. The frequency of this particular filter was also 5 kilohertz and input is also 5, so it is not suggested at all. So either your input frequency should be lesser or you should design a filter with higher cutoff frequency. So I am going to put this, let us say 1 kilohertz signal input. So I am going to get proper plus minus 1. You can see plus 1 minus 1. If you want, you can run it for a little longer time. So go to analyze and simulate, run it for let us say 5 millisecond. Okay. So you will see 5 pulses and very nicely it is appearing. What you can see is very nicely it is appearing. This is my output signal. If you want to observe the input signal also, what was the input signal? Take a voltage probe PR2 and let us run it. So you can see the green signal is input signal and the red signal is output signal. It is like following each other very nicely. Now you wanted to have the input signal to be 5 kilohertz, right? 5 kilohertz. So for that, the cutoff frequency of low pass filter must be more than 5 kilohertz, right? So let us change the value to 10 kilohertz values. So let us say I am going to put FC as 10 kilohertz. Then what will be my R and C values? Let's say 10 nanofarad and 1.59 kilo ohm. So I'll put it 1.59 kilo ohm, 1.59 kilo ohm. Sorry, this is ohm. 1.59 kilo ohm. So this will shift to 10. This will shift to 10 kilohertz, and now my output signal will not attenuate. Okay. Why? Because my low pass filter has increased the cutoff frequency. So let us run it. And you will see a very little attenuation is there. I can run it for little lower time, okay, little lesser time. So let us run it for 1 millisecond. So you'll see very less attenuation is there. There are other factors also that depends on like what is the attenuation or something like that by putting the op amps that you are going to use. Now this I did it using like a band it is going to be used as buffer like unity gain. If you want to increase the gain, what will you do? You can simply put 2 resistors here. So go to place and in that place basic resistors, let us put one resistor here and one more resistor at this place, and let us set some gain. Okay, let us set some gain. So gain, let us set, I am going to set gain as 2, that is 2 by 1, that is minus 2 will be the gain. So 1 volt peak is the input, output will be 2 volts. So let us say I'll put it 2k. So do you think, and let me reduce the like a frequency. So 1 kilohertz was better looking. Okay, and let me change the trace width of output signal as well. Okay, sorry, input signal as well. So green is the input signal, PR2 probe 2, and PR1 is the output signal. Now let us run it and see what is happening. So you can see my input signal is 1 volt peak to peak, and my input signal is 1 volt peak to peak, and my output signal is 3 volt. Why? Because gain has been set to 1 plus R2 by R1, that is 2 by 1, that is 2 plus 1, that is 3 times. So gain is 3 times. Understood? If you run it for longer time, you can run it, not a problem. Let us make it 5 millisecond. So this is how you design your circuit. Okay, so I hope you have a good understanding of how to vary the gain of a low pass filter, or how to design a low pass filter with variable frequencies, how to verify your input signal which will be allowed to pass through the low pass filter, and calculation of low pass filter cutoff frequency using the formula of fc equal to 1 by 2 pi rc. So if you do have any questions or any understanding that is needed based on the like design for first order low pass filter using active elements, that is op amp, you please put down your questions in the comment box and we shall be able to give you answers. Thank you.